Hello guys and welcome to our module 3 of STATA, which entails data cleaning and manipulation. So this module will entail handling of missing values, removing of duplicates, reshaping data, reshaping data, subsetting data, as well as sorting and ordering. So going straight to our first objective of handling missing data. Missing values in STATA are simply represented by a dot uh, if they represent those numeric variables or or an empty string for string variables. And we have miss table. So by running this miss table, we'll provide a summary for missing values. And example, we can say missing table summarized, which means we need a summary of the missing variables across the observations. And drop if missing command in STATA will remove observations with missing values. Example, we have drop if missing, for example, if we are interested in the income column. And now removing duplicates. Remember, duplicates are similar entries that have been entered two or more times. And we need to just write duplicates report, and this one will identify the duplicates report, and this one will identify the duplicated rows or observations. An example, we can issue a command like duplicates report id, and we'll get the missing values based on id. And you have duplicates drop, so this one will remove duplicate observations based on specific variables. Example, duplicates drop id, and we have to force if we have some resistance. And we also look at reshaping data. So reshaping data is used to switch between wide and long data formats. So we are going to look at what is reshape long and what is reshape wide. So reshape long will convert from wide to long format, and it's good for time series or panel data. In fact, in future we are going to understand what time series and what panel data, what are their differences. So reshape data. How to reshape data to long? You just need to issue STATA command reshape long, for example, income based on ID and year. And to go back or to revert back to reshape wide, this is what we have. It will convert from long to wide format. And this is a STATA command, like you issue reshape wide income, comma, ID and year. And we have now subsetting. With subsetting, we use keep, drop, and if conditions. So with keep, it will keep only specified observations or variables. And example include, for example, keep if age is greater than 25. So it means that this code will filter out all observations whose age are 25 years, okay, are above 25 years. Anything below 25 years will be eliminated. And if you can say keep ID, income, and age, then now it will represent all the observations for individuals or respondents whose ID, income, and age are above 25 years of age. And drop command simply drops the specified observations or variables. And example is drop if gender is equal to male. So the STATA will compare where the gender is recorded as male, and it should drop now, which means you'll have to remain with the female respondent. And you can also drop income column, for example, if you want. And now you have if conditions. So if conditions is used with most commands to filter data. Example, list name, age. So it's like telling STATA to list name and age if their age is below 30 years. So all the individuals or respondents from your dataset whose age is lies below 30 years of will be presented. And now we have sorting and ordering. So under sorting and ordering, we have to sort and gsort. Remember, sort will sort your data by one or more variables in ascending order. The keyword here is ascending order. So it will automatically send by ascending order. So for example, you have sort age, and it will sort age by ascending order, which means the youngest guys will be represented first, and the old guys will be at the end of your data set or that column. While gsort is very flexible, it will allow you to sort in both ascending or descending based on your preference. And remember, ascending you'll have to add a plus, and descending you'll have to add a negative. And example, we can say gsort negative income plus age. It means that we need to sort these two columns, income and age, but now income should be sorted in descending, whereas age should be sorted in ascending. Now it is time, guys, to move to our practical part. Our STATA is open, and this is the dataset we are going to use. Module number 3, equivalent of practical part, which entails data cleaning and manipulation. And this is the part of the file that we are going to use, the same file. And so, first thing first, we need to import your data. But for this this practical, well, I'm going to use this dataset label dataset 2 because I did some modification which we need to observe, like maybe duplicates, we have missing values, but now this original dataset is not missing any data, or is not modified in such a way that we can now check some of the stuffs like handling missing values, dropping observations. Okay, no, dropping observation can be applied to both, but something like replacing missing values. So like in this dataset 2, we have missing values of which we are going to use. So let me load this dataset, and what follows is that we want now start by handling the missing values, and we need to show the missing value summary if indeed we have it. So to show the missing value in STATA, we just need to issue the command misstable summarize. Remember, we are just doing what we've done in theoretical part. Now we are doing the equivalent practical part. So if I run this, you realize that the STATA gives us a summary of missing observation. It says that we have two columns with missing observation. We have income and year. We have we have one observation that is affected per each column, but those who have 53 observations that are unaffected. So in short, it means that we have totals of 54 observations, but one is affected. 53 are unaffected, which means there are no missing entries. And to have on unique variables, we have in the income column we have 28 guys with the unique income compensation, and the minimum guy is being compensated to 9,000 USD, and the guy who earns higher earns at 60,000 USD. And the on here we are finding that 53 observations are free of missing data, while one observation is affected. And you have three unique values. You have or three unique years, which means it ranges between 2020 to 2022, which means 2020 you have 2021 and 2022. And now we need to issue a command. First of all, we need to browse the data to check now those data. Maybe you can check it manually. We try to. We are told that the year we have under the year column. Let us try and check the year column. Yes, we've seen this the year column, something is missing, one, and now the other column that was affected was income. So we can trace this income here. We're having something here on income. So this row number 45 of income, something is missing, but you should know something unique, that imagine we have missing values here in health status, but the STATA did not flag this, that we were having some missing value here. There is we also have another one here without missing here missing, but STATA did not record. Why? In fact, we have around, let me just go here, health status, we have one. We have under education, we also have under education we have a missing value here, and health status we have this one, and again we have this one under health status, but it was not recorded. So basically what we are learning is that the miss table command will only give you a summary of missing values for a numerical data, so you need to be keen when using that. So but there is a way you can do by handling those missing values. Maybe you can drop, or what. Dropping is not specific to any kind of column or any kind of variable, so it will drop without any discrimination. So we want to drop some observation with missing values based on income and education. Remember education was not flagged because it was in character format, or it's a string. So we were telling STATA now to drop if missing in income or in education. So any missing values in income or education. Remember, income was flagged that there was only one observation with missing value, but education we had. Let me show you the education. This is the education column. And here's that we have missing value here at observation number 47, but it was not flagged previously when we ran this, because this command only targets the numeric variables. These commands targets the numeric variables, but now we want to drop if missing, if we have missing values on income and education. So let us run that, and we can check from this. We realize that two observations have been deleted. We're being told that way. Now let us try to visualize the data, and the command was to remove duplicates. Okay, so to drop any missing values based on these two columns, income and education. So let us check now the new on income and education. Now when I scroll through the income, you realize now we don't have any missing value, and we can also check that the observation have reduced from 54 to 52. Now let us go to education again. So we realize we don't have any missing value again, but previously we had. So we realize we have successfully dropped those missing entries. Now what follows is, now we want to replace we want to do some data harmonization we want to replace health status is equal to unknown if missing health status. So if someone did not provide the health status, then we will have to issue an alternative response as unknown. So first of all, before we do that, let us again browse our data and navigate to a health status column. Here we have one is missing, another one here, another. Do you have another one? Yes, we have another one here. Yes, we have three missing instances. And now we want to replace these missing instances or missing records for health status variable with unknown. So this is the equivalent command to do that. We want to replace the health status column where the records are missing, and now we need to run this. Now after this one, the command ran successfully. I hope so. Let me go here. Yes, we say that three real changes have been made, which means these three real changes, which means that we had those three missing entities and it was filled. Now let us browse our data and now check. Now we realize there is something called unknown here. We have another unknown here, as well. We have another, should have another unknown somewhere here. Yes, here. And now what follows, we want now to remove duplicates. For example, if we have some duplicates, we can remove them. And before we remove them, we cannot just be blind. We need first of all to test if we have some duplicates. So to check if we have duplicates, we need to issue the command duplicates report are based on ID, and let us run. We realize that we have this table that STATA gives us. We have that duplicates in terms of ID. We have copies, observations, and surplus. We have 1, 2, and 4. So it says that one copy is having 46 observations with no surplus, which means no duplicates. And we have 2 observations or 2 copies with 2 observations, one being a duplicate of another. And we have also 4 copies of 4 observations, with 3 of them having similar records of this extra one. So in short, we are having 4 duplicates in this data set. Maybe before we proceed, we can browse and check. So let us check the duplicates. We can check it manually before we proceed. So are you seeing this? I think you can see some duplicates here. ID number 9 through ID number 12. We have, these are duplicate values, and maybe if we can scan through, yes, I can scan. I have seen one here again. This one, another instance. This is also a duplicate. Yes, I hope you can also see this. And now we want to drop the duplicates with this line of command. Now you realize that 4 observations have been deleted, which means the 4 duplicates have been now dropped. And we can now browse and to check that where are the duplicates. Now before even we check, we can see the final records have been reduced from now 52 to 48. So which means we have reduced the duplicates, we have removed the duplicates. Now guys, the next stage is to move to reshaping data, both wide and long as well as back. And to demonstrate the reshaping, first we need to create a dummy measures. So before I do so, I want to show you how reshaping wide and long looks like. Hello guys, I want to show you how long and wide data looks like. So this is a wide format data and this is a long format data. So I hope you can see the differences, that in wide format data we have significantly more variables but significantly less observations. And on the other hand, the long format has significantly low number of records, low number of or less number of variables, while having large number of observations. That's the difference between long and wide format. And now checking on the column or variable names, can you see here, like you have income underscore 8 2019, income underscore 2020, income underscore 2021. But on long format you just have ID, income, and year. So the year, you have a single column representing year and a single column representing the income. But remember, this is the same data, these are the same data and the same data. So, and this is the long format, this is wide format. Now let us see how we can create this or we can move from long format to wide format and back. To demonstrate reshaping, first we need to create dummy repeated measures. So we want to create, for example, income for 2020, income for 2021, and income for the column 2022. And so for line number 33, we want to create a column called income for the year 2020, and it will be equivalent to income if the year is 2020. So which means that all the income for 2020 will be equivalent for this column. Let me first of all just create this column, and now we can browse the data after creating that column. So I hope you've seen this column that has been generated. So yeah, you can see that all the years for all the income for the year 2021, so the year 2020 have been populated here. Okay, the year is here, in fact, the year and income, and we realize where the year is not 2021, it is now missing, and the year 2020 is still here, the year 2020 is here. Now we want again to do the same, another column here for the year 2021 and the year 2022. So let me now populate these two. I can issue this command at once. Let us summarize our data now. We realize now this is the data set, and we need to also still remember that if we say summarize, it will give us the missing entries for, or missing report for, any numeric column that is having some missing observations. So we have here income underscore 2020, income underscore 2021, and income underscore 2022 being affected. And we are being told that the year column is affected by one observation, but the non-missing observation is at 47. On the other hand, the income for the year 2020 having 31 missing values or observations, and 17 are filled. And for 2021 we have 32 missing, and for 2022 we have 34 missing. And we have the unique columns. In the year 2020 we have 42, and the unique columns for 2021 we have 10. Unique column for 2020 is similar to 2022, which is 12. And for minimum income for 2022 is 19,000, also 29,000 USD, and maximum is 60,000 USD. And for year 2021 we have minimum is 33,000 USD and maximum is 55,000 USD. On the other hand, for the year 2021, minimum income was 30,000 and maximum is 60,000. It's time to drop. We need to drop the original income and year, because we want to avoid conflict during the reshaping. Because now we want to create the reshaping after creating this data, these three columns. Now let us safely drop these two columns, and you realize that the STATA has issued the command here saying that we've already dropped the columns successfully. And we can browse now to confirm that we don't have year and income. Now we don't have the year and income, and we wanted to go back to the original where we had income and year now, and we want again to create now some duplicate report ID based on ID before we proceed. So let me execute and realize that only one copy. We don't have any duplicate now so far, all unique observations. And what follows now, we will need to create our reshape data. So the reshape data, we issue this command as reshape wide. And remember, in fact, our dataset is already in long format. In fact, the dataset is in not long format but wide format. This one. is in wide format. We have income underscore year, so we want to convert it back to wide format. Sorry, to long for we want to convert it to. Okay, I went several steps back. So here, so the dataset is already in long format. Here, it's already in long format. So if we try to issue this command, we are likely to get an error, because it will be given now with the message, will be greeted with the message that the data is already in long format. Okay, why? Nice. We have not run into an error, and we need to note something, that after browsing, let us browse this data. So we've put this data into long format. Are you seeing now? This is the column, and now this is the year. We have year and income, year and income, year and income. And we can summarize to get what happened. So from this, from the result, this is the result we got, that we are being told that number of observations increased from 48 to 144, and the number of variables reduced from 11 to 10. So this simply means that the year variable we created indicate time, that is 20 through 2022, and the variable income underscore 20 underscore 2021 underscore 2022 was merged into a single income column. As you can see, this and format long converted to long, so which means one row per ID was created. And now we can reshape back to wide format by just issuing command reshape wide income and ID and year. So this is the income column that we want to reshape back to long. And issuing this command, we can again see what's happening over here. You see how data has been again reconverted. Income underscore year 2020, 2021, 2022. We are back again to wide format. And now let us see the result from the result window. We are being told that observations now have reduced from 144 to 48, and variables have increased from 10 to 11. Why? Reason being that the year variable now was dropped, no longer needed, and now single variable income was split now back into income underscore 2020, income underscore 2021, and income underscore 2022. And now format was converted back to wide, whereas one row per ID, one column per year. Yes. Now what the next step is to now move to subsetting data. So this is a very interesting part about subsetting data. And for example, we want to use keep, which will only keep observation from the north and south region. For example, we want to keep if region is equal to north. So we are comparing the region where the respondents say that they are from north, or where they say they're from south. So we need to combine all these two. So executing this, we run, and now we can browse this to check what's happening. So we realize that we only have 25 observations, and this 25 observation now represents the individuals from the north and south region. You realize we don't have east region anymore. as well, we can drop observation where age is below 30. For example, you've been collecting your data and realize maybe the research threshold or protocol is that no one should be less than 30 years to participate in that kind of data collection. But we find that through data analysis, you find that someone was aged below 30. So you need to drop that because that person is ineligible. And now we just need to drop age. Okay, before you drop the age, let us first of all check the age columns. The age column, we have other guys who are 25, we have 26, we also have 27 here and 27. So it means, sorry, 27 here. So it means we need to drop, all this will be dropped, in fact, including this 30. So, in fact, not 30 because we said less than 30. So that will be spared. And now let us check after running the command. So let us drop now and try to run this. So now you realize no one is below 30. The younger now is 30 years old. The younger is 30 years old. And as well, you can drop, for example, drop if age, or sorry, drop if gender is equal to female. So, for example, you are doing a research on maybe to you are taking a survey based on pregnant women, but you realize now during gender capture, someone say that they are he or she is okay. Someone say that he is a male, but now the research only targeted female respondents. It means that one will be ineligible respondent. Now you'll have to delete that. In fact, I said the opposite. Suppose that you are doing a research that only targets male counterparts, but now you realize during the survey you captured someone as female. It means that is ineligible respondent, and you have to drop that. And now, if I run this, we drop that successfully, and we can browse. And now you realize that our data only comprises of male, no female anymore. And now we have what we call sorting and ordering. I hope you still remember that sort will sort automatically in ascending order. But if you want in descending order, then you have to use an alternative, which is gsort. So let me sort this region and gender, and you can browse now. So region, we sort region and gender. So these two columns will be sorted based on in fact, now we realize that we only have male because we had filtered female, and all male, fortunately or unfortunately, come from southern region. So this one will not be seen well, but maybe we can try that on age column and see what happens. Or maybe you can let us try to here on unemployment. Let us try to twist on employment, and let us sort, and you can browse. Now you realize that employment has been sorted based on alphabet, so in ascending order. But if it were numbers, it means that, for example, the oldest person will be sorted first. Let us try to sort age. So, and on age we'll use gsort. Let us try gsort on education, and try so in descending order using education. So you realize education, we have PhD and bachelors. Now let us try to sort age in a descending order and try to browse. You realize the older guys are at the top. So the older guy is 50 and the younger guy is 30. We can now create some list to view. The first 5 observations. This is how you, if you want to see the first 5 observation of your data set, this is how you can use it. So this stands for number of observations. So you see the number of observations should not be greater than 5. And the number of observations we're expecting it for region, income, gender, and education. So if we execute this, we need to see this in result window. So we're being told that ambiguous, we don't have income. Yes, we are correct because we had dropped this income previously. And maybe to make sure that we get that one, we can re-execute this command again to run the income, to get back the value for income. So you can run this. Maybe let me, this time I can run the first data set. And now execute line number 98 because the same data set. Now this is what we get, the first 5 observation. We have region based on region, income, gender, education, and similar. So guys, this is the end of module number 3. So please help us by subscribing to our channel, and see you in the next module.